Welcome to Hydraulics and Hydrology course. So we will begin basically Unit 1, which is precipitation, evaporation, and runoff. And before going into details, let's look at some learning objectives. And in this unit, we will look at hydrologic cycle, we will look at mass balance equation, we will look at different volume units, and we will look at evaporation, uh, rainfall, how we measure mean rainfall and how we report rainfall, and we will look at runoff infiltration and computation, and how do we convert point precipitation into aerial precipitation, because that's an important thing. And you will see a list of concept questions. As I go along, I'll identify them. You will be responsible for these concept questions, and you will know the answer to these as we finish Unit 1 to all of these concept questions, basically. So let's start looking at Unit 1. So before Unit 1, let's look at basic introduction to hydrology, and let's see what we can think of uh, the course, the hydrology and hydraulics course actually. So this is a typical hydrologic cycle, and we all know this very well. We see it happening every day. We see it starts with rainfall. You can actually enter the hydrologic cycle at any point, but let's start at rainfall or precipitation. That's a general term. So because precipitation can be in the form of snow, sleet, rain, whatever you can think of falling from the sky in the form of water, basically, different forms. So you have precipitation falling. Part of it will fall on lakes, sea, rivers, but some part of it will fall on land too. And the part that fall on land, part of it will infiltrate into the ground, saturate the ground, and then it will start to run off, and then that's how the water reaches the streams, and the streams uh, combine together, form bigger streams, rivers, and then they can drain into lakes or into seas. And you can think of evaporation occurring from water surfaces and from rivers, from even land. When it gets saturated and the rain stops, the evaporation will occur in two ways: evaporation directly from the soil surfaces, and evaporation can occur as the plants uh, draw water from the soil and evaporate it, and that's called evapotranspiration. So you have a plant uptake. So that's uh, a quick overview of hydrologic cycle. Uh, we will go through more details of hydrologic cycles later on in Unit 1, but just for this purpose, this is pretty good. Actually, this slide is not very good, but this is. So if you look at the white boundary, this is a typical what we call watershed. A watershed is a word that we use, that we say, well, for example, for every river there will be a watershed, which means all the runoff that occurs on that area moves towards that river and eventually flows out from the single point. So let's select some different pens, and it flows out from a single point. All the runoff flows out from a single point, and that's the key to it. So a watershed is an area that when the rain falls and generates runoff, all the runoff moves eventually into these small rivers. If you see, these small rivers goes into big rivers. These two combines to form big river. This come into this, and similarly this river, both of them combine and form a really big river, and it drains out here, and that's the key. So you can basically go to any software, for example GIS, and click on a river, and it will give you the watershed of that point. So you can draw a watershed at a different point in the river. For example, I can draw a watershed for this point, and that will look something, let's say, like this. So that will be a sub-watershed of this watershed. So, which means the key thing is that all the runoff must come out from that area at a single point. So for example, I cannot have a watershed boundary here because there are two points at which the flow is coming out. So that's not right. That will not work. So you must have a single point of exit for all the runoff from that area. And the key thing is all the runoff that is outside this white boundary is going to flow the other way, outside. It's going to flow away from that area. So it's not going to contribute any flow to this to the outflow point. Let's look at something else. We see this on the roads all the time. This is for draining water from the road, or rain from the road, or any precipitation from the road. And we have, these are called inlets. What you see on the surface, this is called inlet. And you have a drain system underneath, and it will take the storm water away and drain it into the river, lakes, at any other outlet point. This part is called gutter. So the water flows from the main road towards the gutter, and the water flows into the gutter, let's say this way, and then it comes into the inlet and drains out. But if you look at carefully at any road, it will have two types of slope. It will have a slope in this direction, and it will have a slope in this direction, so that the water can come from the road towards the edge of the road. That's the whole point. You need to drain the water from the road to the edge of the road, and then have these inlets at some distances, let's say every 200 feet or every 100 meters or so, and you will make sure, and we will look into it, how we design these inlets and the spacing of these inlets so that we can drain the water from the roadway efficiently, because we know what happens when the water ponds on the road. You have hydroplaning, and you can lose control, and that's not a very good feeling. This is another inlet for roadway drainage. You can see it's a different type. For now, you don't have to worry about it. I'm just showing you an overview. We will look into more details into all these inlet types and how they work. You can clearly see the slope of the roadway, and this is called cross slope, and then you have a longitudinal slope. Now look at this scenario where you will say, well, this city has not done a very good job in providing drainage for their roadway system. But that's only one aspect, one way of thinking about this. Maybe there is a perfectly good roadway drainage system, but the rainfall event that occurred here is of such frequency or such return period that it has a lot more runoff than the drainage system was designed for. So let's say every drainage system is designed for some return period or frequency, let's say for 20-year flood or for 50-year flood. But if you get a rainfall event or a storm event that dumps rain, which is bigger than your design return period, then obviously your drainage system is going to overflow because it doesn't have the capacity to remove that amount of runoff. And a lot of people think that, oh, they did not design it well. No, that's not the point. And we will see this throughout this course, that return period becomes a very important aspect of the design, because if you have to decide what return period, and the moment you fix a return period, you are going to think of certain risk. So if you design something for 20 years return period, then 25-year event, rainfall event is going to flood that area, and you have to be able to say, well, that's okay. Do I need to take that risk? Yes. Can I have enough funding that I can design for 100-year rainfall event? Maybe if you do, then you go ahead and do that. But if you don't,